Problem number 4917. In this problem, we have to prove that our triple vector product is equal. The following expression, essentially ACB, this is a triple scalar product, minus ABC. So this is essentially the difference between these triple scalar products. So before getting started, I would like to remind you that A is the vector A1, A2, A3, given its coordinates. And then B is the vector is B1, B2, B3, given its coordinates. And then C is the vector C1, C2, and C3. Okay, so how to prove that? That's a little bit tedious problem. You have to do a lot of calculations here. So first of all, we know that A, B, and C is a determinant, right? It's not just determinant, it's the following product. First of all, we have A1 plus A2J plus A3R cross product with B and C. Meanwhile, cross product B and C is a determinant IJR, B1, B2, B3, C1, C2, and C3. And so this can be rewritten as essentially the vector I, B1, C1 minus C1, B2. So C2 actually here, minus J, B1, C3 minus C1, B3 plus R, B1, C2 minus. So you have to be careful, I made a mistake here. B2, C3 minus C2, B3. It's good that I noticed that. And here it is, B1, C2, C1. That looks pretty straightforward. Now, what we need to do is to multiply, find the cross product, essentially, between A and this result of the product of B and C. And that would be B and C. That would be another determinant, which is A, I, J, and R, A1, A2, A3, and B2, C3 minus C2, B3, B1, C3, actually minus, since there is a minus C1, B3 minus B1, C3, and B1, C2 minus C1, B2, which we can simplify. I, and then I, A2, B1, C2 minus A2, C1, B2 minus A3, C1, B3 plus A3, B1, C3 minus J times A1, B1, C2 minus A1, C1, B2 minus A3, B2, C3 plus A3, B3, C2 plus R times A1, C1, B3 minus A1, B1, C3 minus A2, B2, C3 plus A2, B3, C2. Let me now rearrange these terms to make it more convenient. I is A2, B1, C2 is a 2, right? And then minus A2, B2, C1 minus A3, B3, C1 plus A3, B1, C3 minus J, A1, B1, C2 minus A1, B2, C1 minus A3, B2, C3 plus A3, B3, C2 plus R, A1, B3, C1 minus A1, B1, C3 minus A2, B2, C3 plus A2, B3, C2. All right, now it looks much simpler. What we have to do is to see, first of all, take a look how this triple scalar product looks like. And what is that? So A, C, and B, this is the triple scalar product. And we know that triple scalar product is kind of have the following format here. This is A1 C1 plus A2 C2 plus A3 C3 multiplied by B1I plus BIJ B3R. That's the result of this triple scalar product is the vector, which gives us A1 B1 C1 I. Not that simple. Not that simple. Let me move to another line. So this is A1 B1 C1 plus A2 B1 C2 plus A3 B1 C3 I, and then plus J A1 B2 C1 plus A2 B2 C2 plus A2 B3 C2, and this is J, plus R A3 B1 C3 plus A3 B2 C3 plus A3 B3 C3. Cool. And then A B C, which is this one, A B C. It is essentially A1 B1, which is basically A2 B2 plus A3 C3, or sorry, B3, multiplied by vector C1I plus C2J plus C3R, which can be rewritten as A1 B1 C1 plus A1 B1 C2 plus A1 B1 C3. Oh no. No, wait a second. A1 B1 C1 and then A2 B2 C1 plus A3 B3 C1 I, right? This is I plus J A1 B1 C2 plus A2 B2 C2 plus A3 B3 C C2. This is J and plus R. A1 B1 C3 plus A2 B2 C3 plus A3 B3 C3. Nice. Now let's take a look at the expression above that we already computed here. Let me take my marker here, and so what do we have? How can we potentially simplify that? Well, that's pretty simple, because as you can see, we don't have... So in both of these expressions, AC, B, and BC, we have common terms. For example, A1, B1, C1, right? So this is the same as here, A1, B1, C1. And the same applies for A2, B2, C2. And the same is here, A2, B2, C2, and then A3, BC, C3. And the same is here. So they cancel each other. So we can ignore them. And indeed, we don't have them in the expression above. We don't have A1, B2, C2, so this checks out. Next, let me change the color. And the next thing is we need to find the positive terms first. Let's see. I goes with A2, B1, C2. A2, B1, C2, here it is. That matches. And then A3, B1, C3. A3, B1, C3, that matches. And next, A2. Okay, so positive terms first, sorry. Here it is. This one is positive because it's negative, but it is double negative, so it's going to become positive. A1, B2, C1. A1, B2, C1, here it is. That matches. And then A3, B2, C3. A2, B3, A2, A3, which is a J, A3, B2, C3, A3, B2, C3, A2. Okay, so that looks like there is a typo here because A2. I believe that should be A3. Yes, that should be A3. This is a typo. Should be A3, A3, B3, C2, and the same as here. A3. Alright, so A3, B3, C2. It is actually the negative term, but I believe that should be the positive one. It can be negative. It can be negative. I mean, that should be positive. Let's take a look carefully. Oh yeah, that should be positive. A3, B, C2. It should be positive. I don't think it is negative. A3, B3, C2. Hold on a second. That should be C3. Oh my god, I'm now completely confused. What is that? A1, C1, B2, AC2, C2, A3, C3. With a J, it should be B2. Well, actually it should be B2. And then A3, B2, right? And C3. Guess so. I guess it should be C3. Yes, it is. B2, A3, B2, C3, and now it coincides. Now it matches. Right. Splendid. Great. And now our terms, our positive terms. A1, B3, C1. A1, where it is. A1, B3, C1. I mean, that should be A1. That should not be A3. That should be A1 here. Oh my god. It's very easy to get confused. It's very easy to get lost here because of all these indices. So it's very easy to get confused. A1, yes. So, I mean, R, since this is R, that should be B3 actually, right? That should always be B3. That should be B3. And should be B3 here. And we have A1 and then A2, A3, and B3 is preserved. And the same for C. We have C1, C2, and then C3. Yes, that's right. The only index which remains here is the B3. Okay, so let me see. In that case, this one matches with A1's B3. A1, this is B3. No, that's annoying. Maybe it's just so small that I'm not seeing it correctly. Maybe it's just so tiny that I miss it. And then A2, B3, A2, B3, C2. This one matches. And then negative terms. Okay, so each value matches here the terms above. Now let's see the negative terms. So the positive terms, they checks out here. And now negative terms. Negative terms is A2, B2, C1, A2, B2, C1, yep, that matches. A3, B3, C1, A3, B3, C1, nice. And then A1, B1, C2, A1, B1, C2, cool. A3, B3, C2, A3, B3, C2, cool. And then A1, B1, C3, A1, B1, C3, nice. And then A2, B2, C3, A2, B2, C3, nice. This checks out. There are no terms left. A2, B2, C3, A2, B2, C3, yeah. So there are no terms left here, so everything checks out. And we can conclude that our A, B, C triple cross product equals to AC B minus AB C, the difference of scalar products. Now, I proved that. Sure it is.